Welcome back to Elementary Statistics, Part 20. We are going to be looking at the fourth part of probability. We're going to be looking at the probability of multiple random events. And we're going to be doing, we'll be discussing properties of probability next in relation to multiple events, but we're going to be doing three exercises here. And so the first exercise is, what is the probability of getting all three questions on a quiz correct? In this question, we have multiple events, not one, so that's key. And the probability of getting a question wrong or right is 1 out of 2, so we know that. It's kind of like a tail flip, or I'm sorry, a coin flip where it's heads or tails. But what is the probability of getting all three questions correct? All right, so if you pause the video and try to answer, here's the answer. I'm gonna put out all of the possibilities here. What are all of the possible outcomes? And by the way, when you do this, one of the things that you can do, if it makes more sense to you, is sometimes you can kind of outline in order, like, you know, you see I do correct, 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 then correct, correct, incorrect, etc. But you can sometimes do it that way, depending on what's more organized for you. This is only to prove what we're doing. We'll look at a couple of inverted examples in a second, but this is just to show proof. It probably is not going to be efficient to diagram all the possibilities when you start getting into, like, the probability of an event A that there's 1 out of 20 possibilities, and event B where there's 1 out of 100 possibilities, and then that's going to start getting excessive. So then we're going to use more of the multiplication, which we'll do in a second. Okay, so the probability of that is 1 out of 8. There's 8 possibilities, and one of those results in all three questions being correct. So one of the ways we do this is the probability of A, if it's a random event and it's independent, and that's key. We're going to be looking at dependent events later, but if it's an independent event, in other words, getting a correct question on a quiz for the sake of this example does not affect getting a correct question on 2 or 3, right? So getting the correct answer on question 1 does not impact 2 or 3. So therefore, it's an independent event. So the probability of of 3 events occurring in one scenario of all being correct is a probability of event A times probability of event B times probability of event C, which is 1/2 times 1/2 times 1/2, or 1/8. 1 out of 8 possibilities. And the diagram, of course, proves that. But these are independent events. Like I said, when we discuss dependent events, we'll find that that's not actually the case, that there are relationships there. But because these are independent events, that is, we can use this multiplication property. Now, in the case of random events, the reality of all possible events or outcomes, as we've discussed, it is referred to, we call this a sample space. So up here we see these 8 different events. This is the sample space. The specific event or outcome is a set within that sample space. Note that our question asked about a subset of all 3 questions being correct, or CCC. So this would be that set right there. And yes, if there's 1, it's still a set. Okay. Now the next exercise we have here, and this is where we're going to start getting more into the inverse, just so that we can think about it another way, is what is the probability that a student gets at least 1 question correct? Pause the video and if you can see if you can answer it. Okay, just think about this for a second. When we ask what is the probability that a student gets at least 1 question correct, some of you really smart are probably thinking, well, what we're really asking in this question is, what is the probability that a student gets every question incorrect, right? Because the only scenario in which a student doesn't get 1 question correct is if all 3 of them are incorrect, right? So what is the probability that a student gets the first question incorrect? That would be 1 out of 2. What's the probability that the student gets the second one incorrect? That would be 1 out of 2. What is the probability that the student gets a third one incorrect? That would be 1 out of 2. So 1 out of 2 times 1 out of 2, 1/2 times 1/2 times 1/2, let's say it that way, equals 1/8, right? But we're looking at the inverse of that. So what is the probability of a student getting either correct or incorrect answers if we go back to this? Well, it's 100%, so 1, basically. What is the probability a student gets maybe something right? Well, in this case, there is no maybe, right? So that's 0. So what we'll do in this question is we will subtract 1 out of 8, or 1/8, I should say. We'll subtract that from 1. So 1 minus 1/8 equals 7/8. So the probability that a student gets at least 1 question correct is 7 out of 8 outcomes. And if you look, we can see, and we can prove that there's only 1 outcome there that results in the question being, that results in the student getting everything incorrect, and that's the one highlighted in red. And by the way, the red is indicative of a wrong answer. I do realize I should have used green instead of yellow, just because of how people typically use colors. So the next exercise here is, what is the probability that a student gets at least 2 questions correct? So based on what we know in the previous exercise there, is there an inverted way of thinking about this? Okay, so what is the probability that a student gets at least 2 questions correct? What we're asking in this question as well is, and it's inverted too, is we're really asking what is the probability that a student gets 1 question incorrect, right? That's really all we're asking here. We're not looking at all of the different scenarios. We're just asking what is the probability that a student gets 1 question incorrect. And the probability that a student gets 1 question incorrect is 1 out of 2, right? So let's look. Okay, so that's the result. We see, again, with the set in the proof, we have correct, correct, correct. We have correct, correct, incorrect. We have correct, incorrect, correct. And then the other one in yellow is incorrect, correct, correct. There are 4 out of the 8, 4 of a set out of the 8, and that results, of course, in 1/2. So that essentially is what we're asking is, what is the probability that a student gets 1 question incorrect when we say at least 2 questions correct? Now, the reason why I highlight these latter 2 examples here kind of in the inverted thinking is, in my observation of tutoring people in statistics, and when I took statistics in college, and just, you know, I enjoyed it a lot. Granted, I do invert think. Part of the reason why I'm a good contrarian trader is I do think very inverted. And I realized about that about myself later on. But one of the things that I observed is the students who are really good at math, this is where they start to kind of struggle with probability, because what we've done in these 2 exercises, and I wanted to demonstrate it, is we looked at the question, but we thought about it a little bit differently. We wanted to think about it a little bit deeper, which is when we ask the question, what is the probability that a student gets at least 1 question correct? The real thing we're asking there is, what is the probability that a student gets everything incorrect, right? And so that's where I think some of the students do trip up. So keep that in mind when you see these type of questions, whether it's on your quiz or homework or whatnot, is think about what fundamentally is being asked. The same way with the second question, when we ask, what is the probability that a student gets at least 2 questions correct? What we're really asking is, what is the probability that a student gets 1 question incorrect? Okay, so inverted thinking, it is a little more challenging, and that's just an observation that I made, is that a lot of students who are good at math, they generally don't like stats, and probability is when they start not liking stats. And so we'll be discussing some properties of probability, which will really make things more help make things make more sense. But in this case, the key to always be thinking about when you have these independent random events is what is really being asked, and that will help you solve the question.